For this problem, I'll start by treating it as a homogeneous differential equation. We'll have y double prime minus y prime plus 1/4 times y is equal to 0. So the auxiliary equation will be m squared minus m plus 1/4 is equal to 0. This will factor to m minus 1/2 squared is equal to 0. So our two roots, m1 and m2, will both be equal to 1/2. So the complementary solution, yc, will be in the form c1 times e to the m1x plus c2 times x times e to the m2x. So yc is going to be equal to c1e to the 1/2 x plus c2 times x times e to the 1/2 x. We can now find our particular solution. G of x was given as 3 plus e to the 1/2 x. Ordinarily, I would set yp equal to some constant a to account for this 3, plus some constant b times e to the 1/2 x to account for this e to the 1/2 x term. However, we already have some constant times e to the 1/2 x in our yc, so we have to fix this by multiplying with an extra x. So yp is going to be equal to a plus b times x times e to the 1/2 x. However, we also have some constant times x times e to the 1/2 x in our yc. So to fix this, again, we'll multiply with an additional x. So yp is going to be equal to a plus b times x squared times e to the 1/2 x. Now that we have a yp that doesn't have any terms that are included in the yc, we can now differentiate yp. Yp prime is going to be equal to the derivative of a is going to be 0. For the derivative of the second term, I'll use the product rule. I'll start by differentiating e to the 1/2 x and leave x squared alone. We'll get b times x squared times 1/2 e to the 1/2 x. For the second term of product rule, I'll differentiate the x squared and leave the e term alone. We'll get b times 2x times e to the 1/2 x. So yp prime is going to be equal to 1/2 bx squared e to the 1/2 x plus 2bx e to the 1/2 x. We can take the derivative again. Yp double prime will be equal to, for this first term, I'll use the product rule again, same as I did before. We'll get 1/2 times b times x squared times 1/2 e to the 1/2 x plus 1/2 b times 2x e to the 1/2 x. For the second term, I'll also use the product rule. We'll have plus 2 times b times x times 1/2 e to the 1/2 x plus 2 times b e to the 1/2 x. We can simplify yp double prime. We'll get 1/4 bx squared e to the 1/2 x plus bx e to the 1/2 x plus bx e to the 1/2 x plus 2b e to the 1/2 x. These two terms in the middle will add together. So yp double prime will be equal to 1/4 times bx squared e to the 1/2 x plus 2b x e to the 1/2 x plus 2b e to the 1/2 x. The original differential equation was y double prime minus y prime plus 1/4 times y is equal to 3 plus e to the 1/2 x. Because yp is a solution to this differential equation, we can plug in yp prime, and yp double prime into this differential equation. We'll get 1/4 times bx squared e to the 1/2 x plus 2b x e to the 1/2 x plus 2b e to the 1/2 x minus 1/2 bx squared e to the 1/2 x plus 2b x e to the 1/2 x plus 1/4 times a plus b times x squared e to the 1/2 x is equal to 3 plus e to the 1/2 x. I'll distribute this negative as well as this 1/4. We'll get 1/4 times bx squared e to the 1/2 x plus 2b x e to the 1/2 x plus 2b e to the 1/2 x minus 1/2 b x squared e to the 1/2 x minus 2b x e to the 1/2 x plus 1/4 times a plus 1/4 times bx squared e to the 1/2 x is equal to 3 plus e to the 1/2 x. This 1/4 bx squared e to the 1/2 x term will combine with this 1/4 bx squared e to the 1/2 x term. We'll get 1/2 b x squared e to the 1 half x, but there's also a minus 1 half b x squared e to the 1 half x term, so these two will cancel. We also have a positive 2bx e to the 1 half x term, and a minus 2bx e to the 1 half x term. These two will also cancel. On the left side, we're left with just this 2be to the 1 half x term, as well as this 1/4 a term, and that'll be equal to 3 plus e to the 1 half x. I'll rewrite this a little cleaner. This is 2be to the 1 half x plus 1/4 times a is equal to 3 plus e to the 1 half x. We can now compare coefficients. We can compare the coefficients for the e to the 1 half x term. On the left, it's 2b, and on the right, it's 1. So we can set 2b equal to 1. We can also compare coefficients for the constant term. The constant term on the left is 1/4 a, and the constant term on the right is 3. So we can set 1/4 a equal to 3. We can divide both sides by 2 for this b expression. B will be equal to 1 half, and we can multiply 4 to both terms in the a expression. We'll get a is equal to 12. Earlier, we set yp equal to a plus bx squared e to the 1 half x. So yp is going to be equal to 12 plus 1 half x squared e to the 1 half x. So now that we found yp, we can use it to form our general solution. The general solution is given as y is equal to yc plus yp. So y is going to be equal to c1 times e to the 1 half x plus c2 times x times e to the 1 half x plus yp, which is 12 plus 1 half times x squared times e to the 1 half x. And that is our final answer. If this video helped you, consider subscribing.